Hello, hello. I guess the mic is actually on. My name is Pacent. I work in product management for Boundary. So I know the title of this talk is the latest in secure remote access. It's kind of a theme for Boundary-related talks. We do a lot of announcements around HashiConf. Today, as you saw in the keynote, is very much like the others. So this is actually going to be a talk that focuses on HCP Boundaries GA, all that we have new with that, and how we make good on that promise of basically protecting private access to your network and making sure that your end users don't need to think about that complexity to connect to logical services. So I also want to add that while this is one talk on HCP Boundary, we actually have a whole set of content today to kind of go through both what I'm talking about the cloud service. We'll dive into technical details after my talk at 1:30 today for Jeff Mitchell's talk. Jeff Mitchell is a principal engineer of secure architect for Boundary, who will be kind of diving even deeper into these details. And then at 2:30 this afternoon, we've got a talk with Robin Beck from our Learn education team that will actually offer a workshop to get started with HCP Boundary and make good on exactly the concepts that we're going to be talking about today. So to get started about HCP Boundary and kind of the core value prop that we're trying to address, this goes back to the keynote and kind of the story that Armand told around zero trust security principles in a modern computing environment. Traditional approaches to protect access to infrastructure and applications have very much focused on kind of the network perimeter as the emphasis of security. That comes with all sorts of constraints around network location, either the client IP address or the target that you might want to connect to as the kind of point of security for that workflow. And the problem with this model of kind of, this VPN firewall-based approach of ensuring access to the network, putting your security controls at the point of entry to the network, and then not necessarily having strong controls within that network once you breach, is that it's oftentimes not a matter of when, or not a matter of if, but when someone will get access to that network. And when you do, you need to ensure that that access is protected by kind of fundamental zero trust principles where every single transaction you might have is authenticated and authorized. This becomes very brittle to manage in kind of a modern computing environment when you're spread across multiple cloud providers, when you're spread across different runtime technologies that you need to kind of establish common access controls against and ensure that that's ultimately not based off of the network location of a client or target that you're dealing with, but ultimately a logical identity, and have kind of these common zero trust principles in which, based off of that logical identity, every transaction is authenticated, granularly authorized in terms of what access that identity can take and what services it can connect to and what actions it can take against those services, and then ultimately audited. So we see this kind of common set of zero trust design principles spread across the portfolio of workflows that we try to enable across Vault, Consul, and Boundary. We see this first and foremost, I think, with Vault, as kind of Armand stressed in the keynote, around protecting application identity. So this kind of interchangeably is used between application and machine identity, where you have ultimately some kind of common workflow for secrets management across your infrastructure. Consul for protecting networks, and Boundary, which is really the focus of today's conversation, in being a way to kind of establish these zero trust principles, this way to commonly authenticate human users, authorize their access, and ultimately audit that access against remote systems. So with Boundary, what we've really been building over the course of the last 2 years since Boundary 01 is this common workflow for consistent access across the providers that you might use, in which case a human user, that can be a technical user, your DevOps engineer, developer, database analyst, what have you, can authenticate to their infrastructure with their common identity provider, have very granular authorizations that govern specifically what systems they can access and what actions they can take against those systems. So kind of gone are the days where the traditional VPN-based model, once you have access to that network, you have access to anything. Very much not the case with Boundary. The whole idea being that you can have access to logical services that tightly scope what you can connect to and what actions you can take against those systems. Once I've gone about authenticating and authorizing that user, the key points are being able to connect to that logical service without actually directly exposing network access for that client system. So making sure that they have some mechanism to connect to that without needing to think about the IP address or port that they're connecting to, but instead think of that as a logical service. And then ultimately, when they go about accessing that end system, they want to make sure that that's done in a just-in-time fashion. And that's done, as you'll see today, at multiple different levels within Boundary. So one being the network level, where clients never have direct network access to the systems they're connecting to, but instead go about connecting through Boundary and having that broker network access. And then also being able to integrate with something like HashiCorp Vault to be able to mint single-use credentials for that session, so that you don't have credentials sprawled throughout your infrastructure or source control, but rather are making sure that each credential that gets minted is only be able to be used for that particular session. And one thing that you'll see even beyond kind of our existing credential brokering paradigm is something that we've come out with, which basically enables a passwordless flow from the perspective of the end user, where Boundary itself mints a single-use credential, but never passes that back to a client device, so it's completely obfuscated from end users. But obviously, this workflow is something that we've built over the last 2 years for both the open source offering of Boundary and today with the general availability of HCP Boundary, which I'm really excited to be able to talk about finally and have live after kind of the past 3 years of working this in total across our internal team here. But the whole idea with HCP Boundary is to make this workflow available as a kind of low-touch managed service. The idea being that you can kind of have a one-click deployment model to set up your environment. You can have this kind of consistent workflow to automate the way in which your users can be onboarded into the system and the way in which newly deployed or changed targets can be onboarded into your system, so that ultimately you can kind of standardize this zero trust access model for your technical users, your developers, your DevOps engineers, what have you. So with today's HCP Boundary release, there's a couple things that I want to talk about. The first is that today it's fully available as a managed service. We've been in beta for the last 3 months now since HashiConf EU. This comes with a whole set of enterprise support. It also comes with a production-grade SLA that's consistent with our other services of 3 nines. And today, what I'm really excited about to talk about are some HCP-only use cases and features that are geared towards enterprise governance scenarios. So I'll go through a few of those in this kind of overall access model. But the 3 big things that we're releasing today that weren't yet available within the beta are audit log streaming, credential injection, and then also the ability to broker connections to private vault environments. And I'll go into that, and it's basically the ability to proxy worker vault connections over self-managed workers. And then ultimately, one thing that we're also really excited about with HCP Boundary is the idea that it's a ultimately freemium model to consume. So you can use Boundary in a fully featured capacity, not in like a 1 week or 2 week trial basis, but ultimately like enduringly up to a certain level of usage. So just in the same way that we've kind of made our open source software available to the community, we're really committed to making sure that Boundary is available in a freemium capacity so that practitioners can still get started, even though it's a cloud service, and not have to worry about like the billing involved with that, and that ultimately that commercialization comes more at that enterprise level once you start to adopt it for a company or an organization. So one of the big things that I want to talk about is just this core idea of Boundary, this idea that it's fundamentally a consistent way to manage access to your infrastructure without exposing your network directly to clients and without making those human users have to manage the credential required to access that end system. So ultimately, how does Boundary do that? Let's first talk about this network piece of the puzzle. The first piece of this is that Boundary fundamentally is kind of an identity-aware proxy, if you will. So it has 2 primary components, both for HCP Boundary and Boundary OSS, in which case you have a control plane. That control plane fundamentally serves Boundary's API and portal, and it also manages all state around what targets you have under management. So targets being those kind of infrastructure endpoints. That could be some SSH connection to a Linux host. That could be a database in Azure, what have you. And then ultimately, it also contains state around what identities you have across your infrastructure and what their ultimate access controls and policies are. So when I, as a user, authenticate and authorize to Boundary, I go to that control plane. Once I select a logical service to connect to, I'm assigned a worker node to proxy that connection to the target system. So this has a couple of different, I guess, implications around what this actually looks like in an HCP boundary model. So the first, which is kind of on the screen here, is this idea that HCP as a platform, HashiCorp cloud platform, can manage all of this infrastructure for you. So we can both kind of do the production hardening, high availability, security hardening for both the control plane and the worker nodes that you might use to proxy connections. The other thing that we've been really focused on for the entire development of this managed service is this idea that we can build flexible topologies for how you manage these workers that ultimately make this cloud service usable in even highly secure, highly regulated environments. So the big thing with this is the idea of self-managed workers within Boundary such that you don't actually have to give network access to your private networks, to the data centers that you might be proxying connections to. So let's walk through how this would actually look like. So in this picture, let's consider I have my vault, my existing vault environment for secrets management on some private network that I don't want to give HashiCorp direct access to. Similarly, I might have some target. Again, this could be a Linux host in my AWS VPC. This could be a Kubernetes cluster on premises. But let's say it's just some target resource that I want to connect to remotely that's similarly on a private network that my client doesn't have access to. I can instead drop a worker into these respective networks and have that worker that that I've deployed into these networks securely authenticate to the boundary control plane such that it needs outbound connectivity. So it's a worker-initiated call, meaning that you don't have to expose inbound connections from these private network locations. Again, it's a location-initiated call up to the boundary control plane. And then ultimately, that establishes trust such that the control plane can assign these sessions and also do bidirectional communication to the workers to do things like check out secrets and ultimately assign that session to a client so that when the client actually goes to connect to a service, they're authenticating to Boundary's control plane, getting authorized, and then ultimately connecting over to a worker that sits in my environment, in the customer's environment, such that they never actually have to give direct network access to HashiCorp as a vendor. They never need to expose inbound connections from the public internet or cloud. Again, it's only client accessible in this case. So if the client's on, let's say, a corporate network, you just need to make sure that that worker is exposed in that way. So this kind of, fundamentally crystallizes how Boundary can go about providing this secure access to remote systems without actually having to expose your network directly to the public internet or directly to clients, such that Boundary, again, proxies those connections. The other thing that we're really excited to talk about today, and something that's now available in HCP Boundary, is this idea of passwordless access to infrastructure. And this is enabled through a feature that came out in Boundary.010 called Credential Injection for SSH sessions. The core idea with this is that as an organization, I might have some remote host, again, let's kind of go back to that EC2 example, which has a secret who's managed by Vault. Ultimately, I want to make sure that that secret is single use for a particular session, but then also never ends up on my client device. With credential injection, Boundary can actually inject a credential that it checks out from Vault and insert that into a session from the worker node such that that single-use credential is actually never something that ends up back on that client device. So as we can kind of see here, logically, Boundary can kind of sit in the middle of this. When a user goes to request access to a logical service, Boundary can connect to Vault, securely check out a credential, and then ultimately when it creates a session to that end target system, Boundary injects it into the SSH session, thereby ensuring that it never actually ends up on the end user device. So that's something that we're really excited about today. It's available in HCP Boundary, and again, kind of makes good on this promise of passwordless access to infrastructure. The idea being that, as an end user, I can logically authenticate to Boundary with my identity provider, and then I never need to worry about the credential required to actually access that end system that I'm trying to connect to. So I want to do a quick demo of all of this with HCP Boundary. So what I'll show here is basically a workflow for an end user to connect to a remote system. So ultimately, this will be, we'll say it's a, to use our past HashiConf examples, we've used this Northwind product line. So let's say I'm some developer. I go to connect to my remote infrastructure, either through Boundary Desktop, which you can see here on the left, and then through the CLI. So what I'll do is I'll go through the actual process of connecting to this and making sure that I don't actually have standing network access to the remote host that I'm connecting to, and also I never need to worry about the credential required to connect to that system. So in this particular case, I can authenticate to Boundary. Here I'm just using a username and password, but again, this can be using my trusted identity provider of choice. And you can see that as an end user, I've been given access to 2 different targets here, one giving SSH access, one giving general TCP access to my production grade cluster. Let's say I'm on call or something like that. In this particular circumstance, I can go to my SSH target, and I can see the underlying hosts that I'm providing access to. So in this particular case, we can say that this is a production application, and I can see that it's an ultimate private address that Boundary is going to give resolution to. So just to kind of validate that my client can't resolve that, I can try to SSH to that end host directly. You can see that I don't have standing access from my client device. But instead, when I go through an authentication process with Boundary, once I logically authenticate to Boundary, I can choose that target and initiate a connection. So here you'll see me Boundary connect. This is kind of like the Boundary version of a Terraform apply, if you will, in which case Boundary creates a session to that remote system simply with just Boundary connect SSH that does a couple of things. It provides network access to that remote host. It also does all of the credential management under the hood, in which Boundary checks out that credential from Vault. And then similarly, in the Boundary UI, I can go about closing that session, which is then reflected in the session that I just initiated. So also, I can connect through the Boundary Desktop application. Rather than initially launching that session, I can just create an authenticated channel. So right now, that's opening up a authorized session from my SSH client over that port, and I can go and just SSH directly over that port again without having to provide any sort of credential for that access. So that's one of the big things that we're really excited about with today's launch of HCP Boundary, this idea of kind of passwordless access to infrastructure. So over time, you can expect us to add other types of protocols that we support this type of credential injection for. Similarly, over time, you can see us get these kind of network access problems and this kind of self-managed worker topology be something that we continue to mature. And I know Jeff Mitchell is going to be talking about that even more in the future as his talk is up, I think, at 1:30 today. He'll do an even deeper dive into kind of the mechanics and underlying networking and security bits that enable credential injection, as well as this idea of self-managed workers and how the workers that you deploy in your own environments can be securely connected with the HCP Boundary control plane. So that's, I think, the core ideas that I wanted to talk about today for HCP Boundary. You can make it, you can get started today. It's available on our cloud.hashicorp.com portal. Again, the idea with this being that it's a single-click deployment to get started. We now have enterprise support. It's available to be consumed commercially. And then ultimately, we do have some use cases and features geared towards these enterprise governance scenarios that we're excited about to make available within the managed service. I do want to also say that with today's release, we also have 0.11 for HCP, or excuse me, Boundary OSS that goes live, and then ultimately for HCP Boundary. This, again, is a freemium model. You can get started for free. You can use Boundary. Again, we want to make sure that it's available to be used on a practitioner basis for free and an enduring capacity, not like a 1-week free trial or 2-week free trial. We kind of see our graduation from free tier SaaS to commercial SaaS, the same way that we see that graduation from OSS to enterprise with our other self-managed products. So I really appreciate the time and interest for Boundary. This is pretty much, I think, the close for my talk, but I don't think I can take Q&A on stage, but I'll stick around in front because I'm sure there's going to be a number of questions. Really appreciate it, and I look forward to everybody getting started with HCP Boundary. Thank you.